Real-world data holds the promise of medical breakthroughs, drawing insights from millions of patient records. But the entire system is broken. One review found 66 different research definitions for asthma alone. This chaos creates contaminated study samples, mixing patients who have a disease with those who do not. It is the classic garbage in, garbage out principle. A flawed patient definition ensures a flawed result. We'll now show why this happens, how it invalidates research, and what it means for your RWD study. So, where does this chaos begin? It starts with the fundamental data we are forced to depend on. First, electronic health records were never designed for research. Their main purpose is clinical care and billing. This means EHR data is often incomplete, entered inconsistently, and biased toward reimbursement, not scientific precision. But what about the detailed information buried in doctors' notes? In a moment, you'll see why this is not a simple fix. Claims data is even more problematic. It tracks procedures well, but lacks the vital clinical details to define a patient's actual condition. Worse, billing codes are often chosen to maximize payment, not to accurately document a complex diagnosis for future analysis. This matters because researchers build phenotype algorithms, sets of rules to identify patients, directly from this messy data. To answer our earlier question, tools can read notes, but with only 70 to 90% accuracy, they introduce another layer of error. An algorithm built at one hospital almost always fails at another. The underlying data is too different, making them non-portable. On top of that, clinical coding practices vary immensely between individual doctors and entire health systems, creating total chaos. And even a perfect algorithm degrades. Phenotype drift means definitions and systems change, making your rules obsolete. So you have flawed data and unstable definitions. Now let's see what happens when you try to build a study on this foundation. Remember those 66 definitions for asthma? That is not an anomaly. It is a direct symptom of this systemic failure. The immediate result of this is patient misclassification. Your algorithm generates both false positives and false negatives. Picture your case group contaminated with 20% controls, and your control group with hidden cases. The comparison is already broken. This explains why many findings fail to replicate, especially in psychiatry. Separate studies are unknowingly analyzing different populations. This contamination doesn't just obscure your results. In many cases, it makes them vanish entirely. The obvious answer is to validate every algorithm. Keep watching to find out why this validation process itself is profoundly difficult. First, creating a true gold standard for comparison is extremely hard. For many conditions, diagnosis has a subjective component. The most accurate method, manual chart review by clinicians, is also extraordinarily slow and prohibitively expensive. Because of the high cost, validation often uses a small sample of charts that may not represent the whole population, giving false confidence. And finally, biology itself gets in the way. Phenotypic heterogeneity means one disease can appear in many ways, defying a single definition. Now let's connect these points. Take patient misclassification and apply it to a high-stakes genome-wide association study, or GWAS. Phenotype errors don't just add statistical noise, they actively dilute the signal. A genuine genetic link can be masked and lost. This is why validation matters. The difficulty of doing it is nothing next to the danger of missing a discovery or pointing research the wrong way. It is a catastrophic chain reaction. Flawed data creates bad definitions, which cause misclassification. This is the garbage in that guarantees failure. The power of real-world data is immense, but it is completely negated if the first step, defining the patient cohort, is wrong. This isn't a minor issue. Poor phenotype validation is a primary, predictable, and preventable cause for RWD study failure. The only path forward requires extreme rigor. Transparent, reproducible, and intensely validated phenotype definitions must be the standard. So, before you design, fund, or trust an RWD study, ask one question: how was the phenotype validated? The answer determines everything.